Welcome to our exploration of 4 essential acids: citric acid, acetic acid, phosphoric acid, and tartaric acid. In this series, we delve into the fascinating world of these acids and uncover their roles in various culinary applications and industries. Join us as we discover the tangy essence of citric acid, the versatile uses of acetic acid, the carbonation companion that is phosphoric acid, and the natural tartness of tartaric acid. From enhancing flavors and balancing sweetness to preserving foods and contributing to effervescence, these acids play pivotal roles in our everyday lives. We'll dive into their origins, functions, and how they shape the taste profiles of the products we consume. Whether you're a food enthusiast, a curious learner, or simply intrigued by the science behind flavors, this series is designed to expand your knowledge and appreciation of these remarkable acids. Get ready to embark on a journey where taste and chemistry intertwine, as we explore the captivating world of citric acid, acetic acid, phosphoric acid, and tartaric acid. Citric acid, the versatile acidulant citric acid, is a natural acid that occurs abundantly in citrus fruits such as lemons, limes, oranges, and grapefruits. It is widely used in the food and beverage industry for its versatile properties, providing a tart, acidic taste and various functional benefits. As an acidulant, citric acid is valued for its ability to enhance flavors, balance sweetness, and act as a natural preservative. Its sour taste makes it a popular choice for adding tanginess to beverages, confectionery, jams, jellies, and sauces. Citric acid is also a key ingredient in carbonated drinks, contributing to their characteristic effervescence and refreshing taste. Beyond its flavor-enhancing properties, citric acid plays a vital role as a pH regulator and chelating agent. It helps control acidity and prevents the growth of microorganisms, thereby extending the shelf life of food products. Citric acid is commonly used in canning, as it promotes food safety by creating an acidic environment that inhibits bacterial growth and enzymatic browning. Moreover, citric acid finds applications beyond the food industry. It is widely used in cleaning products, pharmaceuticals, and cosmetics. Due to its chelating properties, citric acid is utilized as a natural cleaning agent to remove mineral deposits, scale, and rust stains. In personal care products, it functions as a pH adjuster, antioxidant, and fragrance fixative. Citric acid's safety and natural origin have contributed to its widespread use as an additive. It is generally recognized as safe by regulatory bodies such as the U.S. Food and Drug Administration and the European Food Safety Authority. In conclusion, citric acid is a versatile acidulant that brings a delightful tanginess to various food and beverage products. Its flavor-enhancing, preservative, and pH-regulating properties make it an invaluable ingredient in the culinary world. Whether it's adding zing to a refreshing drink or maintaining the quality of canned goods, citric acid continues to be a key component in many everyday products we enjoy. Acetic acid, the tangy essence acetic acid, commonly known as vinegar, is a versatile acid that imparts a distinct, tangy taste to a wide range of culinary creations. It is produced through the fermentation of ethanol by acetic acid bacteria and has been used for centuries as a condiment, flavoring agent, and food preservative. In the world of cuisine, acetic acid adds a characteristic sourness to dishes, enhancing their flavors and bringing a delightful zing. It is a key component in various types of vinegar, including white vinegar, apple cider vinegar, balsamic vinegar, and rice vinegar. Each vinegar variety offers unique flavors and can be used in salad dressings, marinades, sauces, pickles, and more. Aside from its taste-enhancing properties, acetic acid also acts as a natural preservative. The acidity of vinegar creates an inhospitable environment for many harmful microorganisms, helping to inhibit their growth and prolong the shelf life of preserved foods. It is particularly effective in pickling, where the acidic environment created by acetic acid prevents spoilage and enhances the flavor and texture of pickled vegetables. Moreover, acetic acid has found applications beyond the kitchen. It is widely used as a cleaning agent due to its antimicrobial properties and ability to dissolve mineral deposits and stains. In household cleaning, acetic acid is commonly used to tackle hard water stains, soap scum, and as a natural alternative to harsh chemical cleaners. It's important to note that while acetic acid is generally safe for consumption, it is highly acidic and should be used in moderation. Excessive consumption of acetic acid or vinegar can potentially have adverse effects on dental health and digestive system. In conclusion, acetic acid, in the form of vinegar, is an essential ingredient that adds a tangy essence to culinary creations. From enhancing flavors in cooking to preserving foods and aiding in household cleaning, acetic acid's versatility and distinctive taste make it a staple in kitchens and households around the world. Phosphoric acid. The tangy companion of carbonation, phosphoric acid is a clear, colorless liquid that plays a significant role in the production of carbonated beverages. As an acidulant, it provides a tangy taste and helps balance sweetness, making it an essential ingredient in the soda industry. One of the primary functions of phosphoric acid is to create the characteristic bite and tanginess found in carbonated drinks. It acts as a flavor enhancer, enhancing the overall taste profile and creating a refreshing sensation. Additionally, phosphoric acid serves as a pH regulator, helping to maintain the desired acidity level in carbonated beverages. Another important role of phosphoric acid in the soda industry is its ability to inhibit microbial growth. The low pH created by the acid prevents the growth of harmful bacteria and molds, contributing to the preservation and extended shelf life of carbonated beverages. Phosphoric acid is also responsible for the effervescence and carbonation process. It reacts with carbon dioxide gas, which is dissolved under pressure in the beverage, forming carbonic acid. This reaction releases CO2 bubbles, creating the fizz and characteristic, sparkling, sensation when the drink is opened or poured. While phosphoric acid is widely used in the production of carbonated beverages, it's important to note that excessive consumption of phosphoric acid can have potential health implications. High intake of phosphoric acid, often through excessive soda consumption, has been associated with adverse effects on bone health and dental enamel erosion. Therefore, moderation is advised when consuming beverages containing phosphoric acid. In summary, phosphoric acid is a crucial component in the production of carbonated beverages. Its tangy taste, pH-regulating properties, preservation benefits, and role in creating carbonation make it an essential companion in the world of sodas. However, it's important to be mindful of consumption and maintain a balanced approach to ensure overall health and well-being. Tartaric acid. The natural acid with tartness and versatility. Tartaric acid is a naturally occurring acid found in various fruits, particularly grapes. It is a key component in winemaking, baking, and the food industry, where it contributes a tart and tangy taste to a wide range of products. One of the primary uses of tartaric acid is in winemaking. It occurs naturally in grapes and plays a crucial role in the fermentation process. During grape ripening, tartaric acid levels increase, contributing to the characteristic acidity of grapes. Winemakers often add tartaric acid to adjust the acidity of wines, enhancing their balance and improving flavor. In baking, tartaric acid acts as a leavening agent. When combined with baking soda, it produces carbon dioxide gas, which helps dough or batter rise during the baking process. This leavening effect makes tartaric acid an essential ingredient in recipes that require light and fluffy baked goods, such as cakes, cookies, and muffins. Tartaric acid also finds applications in the food industry as a flavoring agent and pH regulator. Its tartness enhances the overall taste profile of products like candies, fruit jellies, and carbonated beverages. Additionally, tartaric acid can act as a natural preservative, inhibiting the growth of microorganisms and extending the shelf life of certain food products. Beyond its culinary uses, tartaric acid has various non-food applications. It is commonly used in the production of effervescent tablets and powders, where it contributes to their fizzing and dissolution properties. Tartaric acid is also utilized in the pharmaceutical and cosmetic industries for its pH-adjusting and antioxidant properties. Tartaric acid is generally recognized as safe by regulatory authorities, making it a widely accepted food additive. However, individuals with specific health conditions or sensitivities may need to exercise caution and consult with healthcare professionals. In conclusion, tartaric acid is a versatile natural acid that adds a distinct tartness to a variety of products. From its crucial role in winemaking to its leavening properties in baking and its use as a flavor enhancer and pH regulator, tartaric acid continues to be a valuable ingredient in the culinary and food industries.